Here's a little reminder of what we learned in class on proving triangles congruent. I also have a few examples to show you that are similar to your homework assignment, so keep watching. Figures are congruent if they have exactly the same size and shape. We noticed this was true of figures that were translated, reflected, rotated, or glide reflected. If the two figures are congruent, then matching or corresponding parts must also be congruent. This can also be stated in reverse. If corresponding parts of two triangles are congruent, then the triangles are congruent. So how much do you need to know about two triangles to prove they are congruent? Do you need all 6 parts congruent to say the triangles are congruent? No. We looked at 4 congruence theorems with 3 parts each that showed triangles were congruent. Let's look at each one of them. The first is side, side, side. It says that if in two triangles, 3 sides of one are congruent to 3 sides of the other, then the triangles are congruent. The next is side angle side. It says that if in two triangles, 2 sides and the included angle of one are congruent to 2 sides and the included angle of the other, then the triangles are congruent. Notice the angle must be between the 2 sides. Notice where the angle must be in each of these examples for side angle side to work. Next is angle side angle. It says that if in two triangles, 2 angles and the included side of one are congruent to 2 angles and the included side of the other, then the 2 triangles are congruent. Notice that this time it is the side that must be between the angles. Watch these examples to see where the side must be for angle side angle to work. Lastly, there is an angle side congruence theorem, but listen carefully to how specific the wording is. If in two triangles, 2 angles and a non-included side of one are congruent respectively to 2 angles and the corresponding non-included side of the other, then the triangles are congruent. In other words, the side has to be attached to the same angle in both triangles or else it doesn't work. Keep in mind that there is no side-side angle congruence theorem. This is because you can actually create 2 triangles that are different sizes given 2 side lengths and an angle measure not in between the sides. Also, there is no angle congruence theorem. We saw this when I showed you a dilation of a triangle in class. Remember that the angles stayed the same, but the side lengths were made smaller by 1/2. So here are the 4 triangle congruence theorems that you can use for your assignment. Don't try to use the last 2. They don't work. Now let's try a few. Look at each pair of triangles and determine if they're congruent. For the first one, I notice that a side, then an angle, and then a side is marked. It's true for both triangles. So is side angle side a theorem I can use? Yes. The second set has an angle, then a side, then an angle marked in both triangles. Is angle side angle one of my choices? Yes. The third set has a side, then an angle marked. Is side angle one of my choices? Nope. I'm not certain that these 2 triangles are congruent. There isn't enough information. The last set of triangles has all 3 sides marked on both triangles. This is the easiest one to spot. They're congruent because of side, side, side. 4 more. See if you can come up with a theorem or why it won't work before I do. For the first, I see all angles marked on both triangles. Is angle one of my theorems? It isn't, so the triangles are not necessarily congruent. The second set shows an angle, then a side, then an angle marked. Is angle side angle one of my theorems? Yes, it is. The third set shows a side, then an angle, then a side. I'm getting good at this and recognize side angle side when I see it. The last set shows a side, then an angle. I also remember this one. Side angle is not a theorem I can use. Okay, watch closely on these last examples. You'll notice that each set only has 2 parts marked congruent. That doesn't mean I don't have enough information. Do you see that some of the triangles share sides? The other thing to notice is that some of the triangles have vertical angles in them. That's 2 angles that are made from the same set of lines and are directly opposite of each other. Shared sides and vertical angles can be marked congruent. Here's how it works. On the first example, both triangles share a side. See it? This is called using the reflexive property, meaning that any part of a triangle will be congruent to itself. So now, with that extra mark, I can see side angle side on both triangles. They're congruent. In example 2, I have two angles directly across from each other made from the same two lines. See them? They're called vertical angles and are congruent to each other. Now with the extra mark, this is also showing me side angle side. For the third example, I can see vertical angles again, this time side to side. Mark those, and shockingly or not, I have side angle side again. In the last example, I see that the triangles share a side, so I mark that. Unfortunately, this is now showing side-side angle, which is not a theorem. There isn't enough information. One last thing your assignment will ask you to do is to come up with missing information that will make a triangle congruence theorem work. In the two triangles, I have BC congruent to DE and angle C congruent to angle E. What would I need to use angle side angle? Well, angle C would be the first angle followed by BC for the side. The angle on the other end of BC is B. Do the same on the other triangle. I would need to know angle B is congruent to angle D for angle side angle to work. Next is side angle side. This time I need the sides on the other end of the two angles. That would be sides AC and FE. Last is angle angle side. For that, I would need angles A and F. That's the end of my reminder. I hope it helped and that the assignment is now a bit easier.